Welcome everyone to geometry. We want to continue taking a look at section 20 today, and we're going to pick up at arcs. So arcs are, again, something that I think that we're familiar with, and all that we're referring to when we talk about an arc is just the idea of if we have a circle, if we were to consider just a portion of that circle, say just this portion here maybe, then that small portion would be an arc. So, right, you're just looking at this sort of a shape. Of course, in order for it to be an arc, specifically, it does have to be part of a circle. So we're not saying things that are changing how much they curve. Okay, we would have a constant curvature there in order to have an arc. All right, so if we have three distinct points, A, P, and B on some circle, then the arc APB is defined as follows. And let me move these so we can see the notation. Arc APB. All right, if AB is a diameter of the circle, then the arc, consisting of all the points on the circle on the same side as P, on the same side of AB as P, this type of arc is a semicircle. So it's just a half circle. So let's see here. If we were to refer to this circle here, we would have A here, B here, let's say, right? So you've got a diameter connecting them, and then let's see, if we put P here, then the arc that's being referred to is arc right here. There we go. All right. So that's semicircle. If P is in the interior of the angle AOB, then APB, the arc APB, is the set consisting of points of the circle in the interior of that angle. So that is, let's say we have O, the center of a circle, and here's our circle. Let's put, let's see here. Let's put A right here and B right here. So we have this angle. Then if P, right, the interior of the angle, angles measure less than 180 degrees. So we know we're referring to this area here, not over here, but here. So if P is in the interior of the angle, then we are looking at the arc from here to here. Excellent. So for this guy, we're referring to that. But if we were to have P, actually, let's give that a name here a moment. This is called a minor arc. And in the case that P is in the exterior, right, not in the interior of the angle, then we would find that, let's say P is right there, then the arc that we're referring to in this case would be the one on this side of the angle. There we go. And in this case, this is called a major arc. Excellent. So all of this is essentially below as well. So we have a few different angles here, or a few different arcs. Arc, let's see here, AQC or APC. AQC is a semicircle. So we've got a semicircle here, we have a minor arc, and we have a major arc. Excellent. So notice here that we want to be able to refer to our arcs having a measurement, and we measure them in the same way that we measure angles. So for a minor arc, the measure of the arc is just equal to the measure of the angle formed from the origin, okay, or from the center of the circle. So for a minor arc, the measure of the arc is simply equal to the angle measure. If it's a semicircle, then, right, we would want to say that the measure of that angle is 180 degrees. However, our angle measures cannot exceed or cannot even achieve 180 degrees, nor can they exceed it. So for anything larger than, equal to or larger than 180 degrees, we need to define it alternatively. So if we have a semicircle, we define the measure of the arc to be 180 degrees. And when it's beyond that, when it's a major angle, or a major arc, sorry, then what we are going to give the measurement as 360 degrees, right? The full circle minus the minor would give us the major. So, so for a major arc, it's 360 minus the measure of the angle, because again, angles are between 0 and 180, not inclusive. All right. So we can say that two arcs are congruent, not only if they have the same measure, but they have to be on circles that have the same radius. So there's two components here to showing that two arcs are congruent, right? They need the same radius and they need the same measure. Excellent. So we say that two arcs are congruent, or sorry, we already said congruent. We said two arcs are adjacent to one another if they are on the same circle. So if we have a circle and they have one point in common, so they have an endpoint in common. So let's use something a little bit lighter here. So we might say that this arc, get it filled in nicely here, that arc, and this arc are adjacent because they have this one point in common. Trying to color it in there. Close enough anyway. So this arc and this arc are adjacent because they have the one point in common. All right. So we'd like to take a look at some theorems of arcs, but we'll go ahead and do that in our next video. So I'll see you guys again soon back in section 20.